Next speaker, it's Craig Tape. He's Senior Director at Deluxe Entertainment Services Group. He's also a co-author, Chris Reynolds, who's the Vice President, Global Partnership, Technology and Innovation at Deluxe Entertainment Services. And he's telling us more about the machine translation, so a time text, so it's a very specific case of those analytics. And he says, my machine can read faster than me. Welcome, Greg.
So the new title of the deck is Lost in Transcreation. Hi, my name is Greg Taib, and I'm here to talk about machine translation and time text, more specifically in the film and television industry, and even more specifically for scripted material. So I'm not really talking about broadcast, I'm talking about things that have a lot of creative content. So first, let's take a look at the definition of machine translation. For those of you that don't know, it's more or less automated translation done by computers. So machine translation is already everywhere around us. How many people in this room have used Google Translate to translate a website, or asked where the restroom is when you're in Venezuela, or, all right, a lot of you. I'd say even the majority of you. So some of you may have noticed that the quality of those translations have gotten a lot better in the last few years. But nonetheless, sometimes the translations just don't work. And that's because translation is very complicated. There are a lot of layers, there are nuances, there's a lot of assumptions that people make in conversation that happen when you're talking to someone that we don't even realize that we're analyzing the situation and making decisions on how to respond. And all of those things affect the way that things are translated. In some cases, the way that one word is translated at the beginning of a sentence can affect how another word is translated at the end of the sentence. So we're going to explore some of these themes in this talk, some of the challenges that we have in translation, and how that applies with machine learning, and so on and so forth. I'm going to say and so on and so forth probably 50 times during this presentation, because I'm a little nervous. So let's take a look at this translation telephone game, as I like to call it. We took an English sentence, we had it translated into Spanish, and then retranslated it back into English. And the original sentence is, she awoke to the sound of a loud bang when suddenly, and was suddenly aware that she had fallen asleep in the middle of the technical conference that she had been looking forward to for months. So we ran this through a neural machine translation, and translated back to English, you could see that there's a lot of differences that completely change the meaning of the sentence. One of the most obvious ones is that at some point in this example, the subject of the sentence became transgendered, which is totally rad because it's 2017. But for the sake of translation, that just does not work. So let's take a look at this quote. The good news is that things are getting better. Professor Martin Volk from the Institute of Computational Linguistics in Zurich predicts that in 20 years, or in 2 decades, we'll have completely replaced the need for human translators. Some people agree with that. Some people think it might be faster. Some people think it might not be. And as the previous speaker was saying, anything that takes a lot of creativity will be more difficult to use. So things like dubbing, where you're not only translating but adapting for lip sync, those might be more difficult, and those might take a little more time before automated translation workflows work. So here's a few examples of different types of MT. The top 3 are older versions of machine translation that existed. Machine translation first came about in the early to mid-50s. But you can see on the bottom row, these 3 neural and hybrid solutions all are new and have come out in the last few years. Another way to look at it is that quality is going up. It's funny because you can see that it's going up, although there is no measurement on the y-axis, but it's going up, trust me. So we started with rule-based MT in around the 50s. Sometime in the mid-60s, there was actually a group of scientists that recommended that we just stop trying because it wasn't really working very well, and it's too difficult and it wasn't worth it. Obviously, we haven't. We got to statistical MT, which is more what you guys were using with Google Translate up until a couple years ago, was based on statistical and rule-based combined. And more recently, in the last couple years, the announcement of neural networks for Google Translate was made. And this is really, really, really exciting. The reason it's exciting is because we're already at parity with all of the older versions of machine translation. So statistical machine translation has been developed for, I think, the last 23 years and consistently refined by linguists and programmers and developers and so on and so forth. And neural translation is a couple years old and we're already at parity. So there's a lot of excitement around it because we know exactly what we can do with it and where we can go. At this point, it's just about doing the legwork. So what is a neural network? There are probably a lot more people that are better suited during this conference to tell you about what a neural network is. And I'm sure that you guys already heard a little bit about it, so I'll briefly go over this slide. It's a computer system that's loosely modeled on the human brain, typically organized in layers, learns by example, and then there's different types of neural networks. So a recurrent neural network feeds results back into itself to achieve dynamic temporal behavior, which kind of allows it to learn faster and be more accurate in prediction. I did want to make a quick note, even though we're not talking about speech to text. This is all translation all day. It is a very important piece in an automated supply chain. So Microsoft right now is saying that their systems are at parity with human in terms of speech recognition and speech to text. I'd love to see that because I'm still not. I'm like many of you. I'll say like, where's the nearest In-N-Out? And my phone asks, do you want to listen to Twist and Shout? And I obviously say yes because it's a great song. But we're not quite there yet. And what we're finding, or what I'm finding in the research, is that especially when it comes to media, the film industry, television, we're finding between 60 and 85% accuracy. And the reasons for that are varied. I mean, some of it has to do with noise. Localization companies might not have a clean recording of dialogue. We might not have separated music and effects. So if we're trying to do speech to text and there's like transformers flying around and explosions, it might not work very well. Music is another piece. Music is in the same tonal range as the human voice often, so it makes it very difficult to separate that dialogue and understand what it's saying. No. So let's talk about localization in film and television. The golden rule in localization is to keep the original intent of the director intact, and this plays into the creativity of it. There are lots of subtleties that come about when you're watching a film that need to be translated correctly. And in this case, to achieve that, we're not just translating, we're transcreating. So what does that mean, transcreating? Translation is converting content from one language to another, whereas transcreating is translating the language, applying local preferences, cultural references, colloquialisms, and really recreating for a new audience. Some of my favorite examples have to do with numbers. If you watch the film Any Given Sunday in France, they're not going to talk about the 9.11 meter line. They're going to talk about the 10-yard line when we're talking about a football game. So a translation should always read like the text was originally written in the new language, but transcreation sounds like the entire concept was conceived in that language. And that's really important for a creative industry like film and television. And with that comes a lot of challenges. So Stanley Kubrick understood the importance of this with a film, The Shining, that I'm sure you've all seen. There's a very integral scene and very impactful scene in which we discover that Jack has been writing his novel for 2 months, and all it says is all work and no play makes Jack a dull boy. Kubrick understood that if a person was in France watching the French dub of this film, and it's all in French, and then all of a sudden they're confronted with a page that's written in English and has a little subtitle, it might not be as impactful for the audience. So it's important to note that one of the biggest challenges for a filmmaker is keeping the audience in suspension of disbelief. And if you're not transcreating and you have these weird translations, suspension of disbelief quickly disappears, and then your audience is left kind of figuring out what's going on, or maybe not that happy or not interested. So Stanley Kubrick not only translated, but he actually made some different expressions for different languages. Like in French, it was one have is worth more than two will haves. So he was transcreating before a lot of other people were even thinking about this, ahead of his time as a filmmaker and also as a localization expert. So examples of nuances that go into media localization and transcreation. And trust me, I'm getting to the machine translation part, but before we get to that, it's important for you guys to understand the challenges that we face in localizing content. So adaptation, we talked about this briefly, with the bad example, I now understand, of the 10-yard line versus 9.4 meter line. But we're adapting for local cultures, territory preferences, even humor. Humor doesn't translate the same in some languages as it does in others. For this example, I tried to come up with a great pun name for the cat in this example, and then I tried to translate it into Spanish and realized there was no way I was going to be able to do that. But let's look at this example for adaptation. The English sentence I am transcreating is, our cat fell into a pool of palm olive and survived. I guess he only has 8 lives left. So if we look at the transcreation of that, we're going beyond just translating. We're not just replacing the words so that somebody understands the sentence. We're applying the local preferences. So in this instance, the local equivalent to palm olive in Latin American speaking countries could be acción. So we switched out palm olive for acción. And cats, this is really interesting. Cats in Latin American countries and in Brazil only have 7 lives, whereas our cats have 9 lives. Maybe it's because of how well we treat them in yoga or something like that. But our cats have 9 lives. So in this sentence, if we sent this off to a customer saying cats only have 8 lives, or this cat only has 8 lives left, they wouldn't understand what was going on, and it would take them out of the scene, and then all hell breaks loose. Not really, but So other important pieces to localizing are context and tone. These are often identifiers for satire, sarcasm, humor, and they're often understood from visual aids and audible aids. So let's say we have a scene with 2 characters who are slinging insults at each other. If both characters are smiling and laughing, you know that it's in jest and it might be showing signs of endearment towards each other. But if their brows are furrowed and they're speaking with an angry tone, we know that that should be translated differently. Chunking is another piece that we don't often think about, and that's basically how we naturally split up sentences to read naturally. So let's say there's a scene and there's a long pause while somebody is thinking about what to say as an example. If we make the pauses, if we translate it in a way that the right words aren't in the first part and the pause isn't at an appropriate place, it'll also take the audience out because it won't read naturally. Or in other examples, maybe grammatical structure between English and a lot of foreign languages is reversed. So if you're doing a word-for-word translation, it might not make sense, but you also don't want to reveal something important that's about to happen in the plot of the film or television show 3 seconds before it happens. That's kind of also would take somebody out of, it would be less impactful for the audience. And then another thing to consider is those pesky client style guidelines and technical specs. Subtitles they're kind of truncated translations. So because of the amount of time that words appear on screen and how much readability speed the average human is capable of executing, you guys know what I mean. Subtitles are usually truncated. So we're not only translating, we're making it more condensed, making the translation more condensed, while still keeping the original director's intent intact. And that's not always easy to do. And that's something that I think one of the figures I read is that right now machine translation has like an 8% fail rate of being over the line in terms of how much space they are putting in their, or how many words they're putting on a line in their translation. And chunking is actually another piece that machine translation doesn't do very well. Again, anything that's creative is more difficult to do and will take some more development and legwork on our end to achieve in the long run. So machine translation is great for translation. What will make it great for transcreation? Training is really what it comes down to, training neural networks. And this is the area that right now the industry is really focused on. I was originally going to play a scene from Arrival, but nobody responded to my email from Paramount. You might be in this room, whoever I emailed. But this is a fantastic movie. I definitely recommend that all of you see it. Because it's disguised as a sci-fi film, but it's really a film about language. And in this scene, the linguist goes into all of the handshakes that are made and all of the assumptions that we make in communication and how it might be difficult, not how it might be difficult, we can't assume that an alien is going to understand all of those pieces. And in this case, we can't assume that a robot's going to understand those pieces because they're not. We need to train them to, not even to understand, but to know how to parse information and create a usable output. And that's what this comes down to, by the way. Our goal is not only just to create a translation, but to create a translation that is usable, that is at the quality that we all expect, and that takes account for all of the things that we've talked about in the previous few slides. So in order for AI to translate human speech correctly, it must account for context, tone, sarcasm, and all of the nuances of language. How are we doing that? Or how are we attempting to do that, and how do we plan on doing that, is to connect multiple neural networks together that are targeted for specific functions. So, we can have maybe a neural network that's focused on face recognition and understanding emotions, one that's focused on tone recognition, and basically all feeding data into the same place to come up with a more accurate output. In terms of machine translation accuracy today, I actually spent a good amount of time looking for some numbers that I could put up here, but I eventually, and this sounds like such a cop-out, but I eventually decided not to put any numbers up here because the results vary so widely that I didn't want you guys leaving here with a percentage in your head that you then throw out at a dinner party to impress people and then have somebody else say, well, I heard. So even the most, what we do know is that even the most accurate results of machine translation require human involvement. Somebody needs to come in and check out what's going on. Because even if we're 100% sure that it's accurate 95% of the time, or I'm sorry, we're 95% sure that it's accurate 100% of the time, that 5% results in the need for somebody to come in and review the work that the machine translation has done. The quality of your machine translation is heavily dependent on the quality of the data corpus you train with. And I isolated this fact because the good news is that in the entertainment industry, we have tens of millions of hours of translated content that was not only translated, but it was translated by professional translators. It was QA'd by professional quality assurance operators, and in some cases QA'd twice, 3 times, or maybe even over the years 5, 6 times. So we have an extremely great data corpus to train the neural networks with. And it's cause for a lot of excitement. And basically, that's what we're starting to do. Take this content, take the millions of hours of verified, acceptable translations that we have, and feed them into a neural network so that it can train itself to be better at translating. So how do we start using machine translation in a supply chain today? We're already doing that. And the answer to this is pretty simple. It's as an aid. Right now, a type of workflow that you'd see common in the supply chain is a machine translation to start, that then goes to a translator, that then goes to QC, and the translator uses that translation as a starting point, corrects any issues that they see, and then feeds the results back into the neural network to train it to be even better in the future. Again, accuracy of efficiency gains in this model are difficult to calculate, but recently some tests done show between 39 and 47% productivity gains, depending on the methods applied. Now, I do want to point out that this is also, again, varies widely. I think that I saw a statistic somewhere that with certain languages like Latin Spanish, which you'd think was pretty far up there considering how much it's used in the world compared to things like Swahili, let's say. But I read that in some instances, Latin Spanish, it actually takes the same amount of time with a pre-translation, and even some translators take longer. So we're kind of all over the place, but we are using machine translation as an aid. How else are we using as an aid? For back translation. So we're using machine translation to translate back from foreign languages into English so that technical operators, QCers, even client service reps can make use of the back translation and make sure that, as they're doing their technical checks, are the subtitles in sync with picture, yes or no? It gives them a tool to do that. In terms of client service reps, it lets them troubleshoot issues more quickly, and it empowers them to find solutions to problems on their own. So with the advent of this workflow, we're coming across a new role that's needed. I gotta make sure I'm not gonna fall off the stage. The new role is the post-editor. So we're finding that translators, when they have a translation provided to them already, don't necessarily have all of the QC skills that they need to complete the job accurately and efficiently. And then QCers, on the other hand, don't have all of the translation skills that they need if they come across an area in which there's 6 lines in a row that need to be translated from scratch. So we have a new role that's emerging, which is a post-editor, which combines some of the skills of a translator and some of a QC operator. One thing that this role requires is a positive attitude towards a machine translation. As many of you can imagine, translators aren't all necessarily thrilled about working with a machine to train it to do translations cheaper, more efficiently without them. So we do have this issue, and the post-editor is the new role that's emerging out of it. And the post-editor would work in a distributed workforce. Using distributed workforce, we can use post-editors from around the world. We can call them up, and if we need to do more work more quickly, we can scale up pretty easily. But as mentioned before, a cloud environment is really great for training MT because we're feeding data back into the system. So with a distributed workforce and machine translation combined, we can achieve this and help train the machine faster. We can also, with a distributed workforce, help identify areas of expertise. Like, let's say a user is, or a post operator is an expert with horror movies. That can help because horror movies should be translated slightly differently than, let's say, a comedy. You want to keep the tension there, and you want to keep it dark when you're translating a horror movie. So the future. So what do we need to do before we can achieve fully automated workflows? There's a lot to do, and I think that we're still a while away from it. But we can provide multiple data inputs that machine translation alone doesn't have. So, object recognition, emotion detection. I talked about this a little earlier. I jumped the gun on this slide. And then we can combine these to effectively transcreate rather than translate. As I said before, machine translation currently is great for translation. It's not great at transcreation. And before we can get there, we need to train to solve for all of the problems that I went over today. And then once we have all those things, we're currently lost in transcreation. Once we resolve the problems, it'll be Suntory time. A little reference to Lost in Translation. Thank you guys very much.